So there was some sort of formula.
Yep.
It was like, and they give you these formulas, by the way.
Yep.
Okay.
And from going through the exam questions, it doesn't appear that you have to prove them. So I didn't waste any time going through the whole proof. It's not a waste, but anyway.
So I'm guessing it says in terms of tan point. So does it just want me to sub in tan 45 plus tan 30 over 1 minus tan 45 times tan 30?
Yep. And then part B would be you put it in your calculator, and then you get 2 plus root 3. And even though it's only 2 marks, what I noticed is you have to put in each one. So you'd say tan 45 is whatever. Hang on. So tan 45 is 3 plus root 3. Tan 30 is also 3 plus root 3. Okay. And so you can see there, they put 3 plus root 3 everywhere. So they actually did this middle step.
Yeah.
So don't leave that one out. Other than that, you're good. This one is the same thing. How would you do part B? And it's a hence type of question. So we might be able to skip A.
So how would I do part B? Sorry.
Yeah.
I need to now. So do I need to take the answer root 2 minus root 6 over 4, and then I need to factorize it? Is that what?
So cos 105 is this fraction. Sec 105. What do you do with that?
So that's 1 over cos 105.
Yeah.
Oh, and so will that be equals to 1 over root 2 minus root 6 divided by 4?
Yep. And which is the same as flipping the fraction, whichever way you prefer. And go on, stick that in your calculator.
So yeah, minus roots. I got minus root 6 minus root 2. If I read that correctly, I put, yeah.
And so, how can you write it in that form?
Sorry, it was minus root 6 minus root 2.
Sorry.
In that form. So do I now? Yeah. So if I divide it by minus root 6.
It's an expression. Can't divide.
I'll factorize minus root 6. Sorry.
Yeah, they don't both have 6 in common.
Oh, minus root 2. Sorry.
That'll do.
And that'll become 1 plus root 3.
That's it. And so just for the sake of it, that would be root 3 plus 1, and then you flip it to be that. What is A? What is B?
A is equals to 2, B is equals to 3.
Here we go. Yes, so cos 105 is this fraction, sec 105 is the reciprocal. Flip it, calculator, and factorize. A is 2, B is 3. Any questions?
No.
Good. This is very similar. Put it in a tan of something minus something. Just put it in the formula. Tan pi over 4 as A. Tan pi over 6 as B. And then you put it in a calculator and you should get that answer. Yep. And you write each one individually. Tan pi over 4 is 1. Tan pi over 6 is root 3 over 3. Okay. To duplicate, my mistake. Okay, addition angle formulae. Grand. Okay, double angle formulae. What's this thing about? So sine A plus B, let B be equal to A. So sine A plus B, let B also be equal to A. So it becomes sine A plus A. So sub that into our formula. What do you get?
You would get sine A cos A plus cos A sine A.
Simplify.
So 2 sine A cos A.
Yeah, it's like xy plus yx. Same thing. And so, oh, it's not plus ending, just that. You could do the same with tan. Just do tan A plus A and simplify. And you can do the same with cos A plus A. And there's a few different ways of writing the cos one. Cos squared A minus sine squared A. So that's a mixture of both of them. Rarely used. This one is just cos, used a lot. This one is just sine, used a lot. And in the good old days, you would only use the very last one. I miss those days. And my guess is they're going to make us use this thing here. Looks like difference of two squares as well.
Yep.
Okay, hold on. Let me copy this double angle formulae thing. Okay. How about this?
So, would I have to like solve cos squared A to get to use that, or
It's not an equation. Can't solve it.
oh yeah, sorry, yeah. Cos squared 50.
Where do you see cos squared something minus sine squared something?
So that will be just cos. Will that just be cos 2 times 50?
Yep.
And so cos 100.
Yep. And so classic. So it's a good thing I'm using the questions from the book, because that stuff never used to come up. And there you go, very first question. Okay, B.
So I'm guessing it'll be 2 pi over 6 tan. Yeah. Will that just be tan 2 pi over 6?
Yeah. Simplify.
And so that will be a third pi.
Okay, that's actually even better. I was going to say tan pi over 3. Wait, is that what you meant? Tan a third pi?
I meant like tan a third pi.
Yeah.
Yeah.
I just realized. Put that in the calculator. See, does it actually get even simpler? See, it says as a single trig ratio. Go on, try it.
So does it want it in degrees form?
Pi, radians.
Oh. Yeah, root 3.
Root 3, is it? Okay, so that's even simpler. So let's go back to part A, sorry. So we have to go back to degrees for that one.
And so no, it gives like a long number for cos 100.
Okay, so it might even be the same. Part B, they asked for it as a trig ratio, and we gave it as just a number. Hey, I prefer root 3 than tan pi over 3, but anyway. C.
So that'll be 4 sine 70 over 1 over cos 70.
Mm-hmm.
And would that make it cos 70 over 4 sine 70?
So I will rewrite the question as divided by,
Yeah.
which helps me with these things. 4 sine 70. Sec 70 is 1 over cos 70. So what do you do here?
You change flip.
Yep.
And so that'll be 4 sine 70 times cos 70, which will be 4 sine 70 cos 70.
Yeah, cos 70. It says single trig ratio. Is there one of these that it could be?
I don't know, would I have to factorize 2 for 2 sine A cos A? Or,
Yeah. So if you factorize out 2, you get 2 sine 70 cos 70.
and then would I then sub in 2 and then 2 sine 70 cos 70? Oh, I've already done that. Also, will that just be 2 sine 2? Oh no, 2 sine 140.
Yep, I think so. So that's 2 sine 140. I hope. 2 sine 140. That was tan pi over 3, and that was cos 100. Okay, so they wanted it as a trig thing, so we didn't need to go to the root 3. That's all right. And the other two didn't become exact values either. Tan of some... Yeah, okay. And so this was these things, but in reverse. So, I don't like the order the book put them in. I think they should have given you, like, the other way, but anyway. Yeah, this is in reverse. So cos squared 50 minus sine squared 50. You look it up, that matches here. And so that's cos 250, so cos 100. Any questions with these?
No.
And these ultimately come from what we were doing the first time, last time, with a plus b, except now it's just a plus a, so it's the same angle if those two parts are the same as each other. Okay. How about this? Hang on. Hold on. Where's this thing? There we go.
So when it says eliminate theta, does that mean like make theta equal to 0 or something like that?
It means like maybe like make theta the subject or something to do with theta the subject, then you'd sub something else in its place.
So would I have to do like sine minus 1 of 3x is equals to theta?
Let's try this way. I think it won't work. So sine, I think it would be x over 3.
All right. Okay.
So I'll call it arc sine.
Yeah.
So arc sine x over 3
Yeah.
equals theta.
And then should I then do y minus? I would have to simplify in the end, but would it be something like y minus 3 over? No, would it be like arc cos of y minus 3 divided by minus 4 over 2?
Y minus 3 over, I believe it would be minus 4. Why do you have to do everything in one go? Is it like that, something? So that's equal to theta?
Yeah.
And then make those two equal to each other?
Yeah.
I can see what you're thinking. I'll tell you why I don't think this is correct. It's because you will lose half of the answers. You will lose the negative answers.
Right. Okay.
I think that's why. The real way is much simpler. What is cos 2 theta the same as?
Cos squared theta minus sine squared theta.
Cos squared theta. Let's use. Let me take on a hunch. Let's use the sine one down the end.
So 1 minus sine squared theta.
2 sine squared theta.
Yep.
Hang on. Yep. Okay. Make sine squared theta the subject.
So that be y is equals to minus 1 plus 2 sine squared theta.
Plus. What
2
is?
squared theta.
Is it not 8 sine squared theta? Why do you have to do everything in your head?
Wait, I do 3. If I do 3, can I not do like 3 minus 4 and then time expand it like that?
Bidmus, there's a time sign in there. So you have to expand the bracket first.
Okay. So, yeah.
So it's minus 1 plus 8 sine squared theta, I believe.
Yeah.
Make sine squared the subject.
So, y plus 1 over 8.
Is equal to sine squared theta. In this one, make sine squared theta the subject.
So, will that be 2 sine?
Hold on. This one
So,
here, it's not a double angle formula.
I'll just make sine theta the subject.
Yeah.
So x over 3.
And so what is sine squared theta?
X over 3 squared.
Yeah. And now what can you do?
I can do x over 3 squared equals to y plus 1 over 8.
Yeah, and I'll just simplify it down to x squared over 9. Just y plus 1 over 8. You know when you square root x squared, you get two answers, plus or minus?
Yep.
That's why this way up here, if you were to draw this as a graph, if you were to put into graphical calculator, arc sine x over 3 equals arc cos y minus 3 over minus 4 times 2, you'd get the positive half of the graph. You'd get the top part. If you were to put this into your graphical calculator, you would get all of the graph. You get the bottom of it as well. This contains all the solutions. This one up here does not. Let's see, did they do something? Oh, they made y the subject. Okay. They didn't say that though, did they? Oh, express y in terms of x. Okay, so they wanted you to make it y equals. All right. What would it be as y equals?
So 8x squared over 9 minus 1.
Yep. That's it. There we go. And they didn't even expand that square thing. All right, fair enough. Yes, so don't go the arc cos and arc sine way. And another reason as well is if you have like sine squared and cos squared, if you can add those together, you get 1 and it eliminates it. But yeah, you go to a higher power instead of inverse to keep the positive and negative. Any questions about that?
No.
Yeah, tricky. Let's see. Before we do this one was. I just want to see. I believe so. Okay, let's try this one.
Okay. Express C in terms of a.
So that means your answer should be C equals, and it should only have A's over here.
Yeah.
There should be no X or any other letter.
So should I make X equals for both sides?
You could. In our previous one, we made like sine squared the same on both sides. So it kind of depends on what you can easily make the same on both.
Oh, should I do actually oh, so let's see. Should I do 1 minus 2 sine squared x?
I think so. So C equals 1 minus 2 sine squared x.
And but for a equals to 2 sine x, is that the one I should be making x a subject or no?
Make sine squared x the subject.
So a over 2 equals to sine x.
Yeah.
And then a squared over 4 equals to.
Yep.
Should I do now? So it needs to be C is equals to A.
Yep.
And so C is equals to cos 2x. So do I need to somehow get cos 2x from that?
At the moment, C has an x in it because of sine squared x. Sine squared x is equal to a squared over 4.
Yep. Oh, right. So it will be 1 minus 2 times a squared over 4.
Yep.
That's and it. That. Oh, was that it? Okay.
Oh, you could simplify it. It's all good. But, yep. Yep, that's it. So and you could have made x the subject and then make the x subject in the other and expand. This way was actually more efficient than our previous one. Like this one has sine, this one has sine, and so this one like naturally went to sine squared x. So instead of square rooting where you would lose the negative, you square the other one. So you bring it up.
Yeah.
Okay, B.
Okay, so so D is equals to tan 2x. Well, I should then do 2 times tan x over 1 minus tan squared x.
Yep.
So and if you sub in for tan x to sine x over 2 cos x?
Yep. So I'm going to split it into dividing fractions instead. So that's 2 sine x over cos x. Okay. Divided by
1 minus tan. Oh, actually, should I change that as well?
okay.
And so would that be 1 minus sine squared over cos squared x?
And x over cos squared x.
And so together the denominator is the same. Should I try times the cos x on the left side?
Nope. I would make this one fraction on the right.
So that would be that would be cos squared x minus sine squared x over cos squared x.
Yeah, so now you're just dividing one fraction by another, which is easier.
Yeah.
Okay, what is next?
Keep, change, flip.
Yeah. Before we do that, and you're correct, I'm just wondering, can we make this simpler? So we're looking to put in like a and b and stuff. A is 2 sine x. Aha. So what can we do there?
Should we sub in the a's and b's?
We could try it.
So that would be so a is 2 sine x.
Yep.
B is 2 cos x. So should I do a over half b?
Yeah, I might regret this, but we'll see. How about the other one? Anything we can do there?
So so a is 2 sine x. Oh, would it be cos 2x?
Yep, I believe so. So that's divided by cos 2x.
Over over half b squared.
Yep. Squared. Okay, what is next?
Times them together.
Yeah, keep, change, flip. Okay, go for it. I'm just gonna make some extra space. Yeah. Okay, keep, change, flip. What do you get? And actually, there is a bit more you can do in terms of A and B.
Yeah.
What could you do?
I'm guessing make cos 2x a or b.
Yeah. What is cos 2x?
That would be so cos 2x is c.
So cos 2x is c. Cos 2x is the same as c. And I'll give you the benefit of the doubt because you don't have the part A. What did we say c was equal to?
Well, you said that c is equals to 1 minus a squared over 2, right?
Okay. So that's 1 minus a squared over 2. I'm going to call that a half a squared.
Yeah.
Okay, now you can do whatever you want.
Now keep change flip.
Yep.
And that would be equals to... Would I be allowed to just put the keep change flip and then after just put so D is equals to 2AB B squared minus A squared? Or is it 2A?
Huh. I like your thinking. Maybe it's a 3 marker. A half B and a half B squared. You're left with just a half B. Seems like a jump. Let's see. So if we did keep change flip, we're going to get a half AB over 1 minus a half A squared. That, did I flip them? Yeah. So that a half can go on the bottom. So like AB over like 1 over 2. So 2, 1 minus a half A squared. AB, that is 2 minus A squared. Did that work out? Not really. We don't have a B on the bottom. You could... what did we... Let's see. So part A, 1 minus A squared over 2. They found some easy way to do it, did they? I don't know. Seemed like it was the same. Show that D is equal to this. So D is equal to tan 2x. Yeah, hang on. D is equal to tan 2x, which is 2 tan x. Hang on, 2 tan x. Sine x is A. Cos x uh, 2 times A over B is 2A over B.
Yeah.
B isn't cos x, B is 2 cos x. Nope, Bookie's not right about that. Am I crazy? 2A over B is the same as 2A over B. And that's because 2 is the same as 2 over 1. Yeah. A was 2 sine x. So that would be 4 sine x. And B was 2. That's some magic. How am I supposed to... They wrote an unsimplified fraction. Come on, Bookie, don't do that to me. Okay, not the easiest question. How are we supposed to know this? You know what? I liked your idea. You get to this stage and then you just say it's equal to 2ab over b squared minus a squared. The reason being is because that's what they did with this thing. Like 1 minus a over b squared becomes b squared minus a squared. Sure it does. Okay. Yeah, that's exactly what you do there. For a 3 marker. Yep, I think you have the idea. Any questions about that?
No.
Okay. Let's see. So this is solving. We'll get there. Solving. Yep. Oops. I have to get this thing back again. Okay, let's try this one.
Okay.
So, um, so does it want me to get like? Do I need to get like sin x to be the subject of both of them or something?
No, it's quite a difficult one. I think I mentioned it. Book is making a fool out of me. This one.
Oh yeah.
So cos 2x is the same as
Cos x plus cos x.
that's 2 cos x.
Also, cos 2x is cos squared x minus sine squared x.
Yeah. Any idea what you can do with that?
And that's equals to n squared.
No. Because n squared would have a minus 2 sine x cos x in the middle. This doesn't. Difference of 2 squares.
So, do I need to use the cos squared x plus sine squared x equals to 1 formula here?
Cos squared x plus sine squared x is 1. Difference of 2 squares. X squared minus 9. Factorize.
X minus 3, x plus 3.
Yeah. This one.
So, cos x minus sine x, cos x plus sine x.
Yeah. That look familiar?
Yeah, it's mn, isn't it?
Yep. And there you go. Mn. Write down in terms of the value. Yeah, there we go. Mn. Very, very difficult to spot that. I just know from brutal experience that this here is difference of 2 squares. Cos a plus sine a, cos a minus sine a. And so I kind of suspected a trick with that one. And so, okay, so you can see how exam stuff changed in recent years, and so they're massively going for this identity now. They used to be these two, and it was like mostly sine for whatever reason. Now it's like this one. Man, there you go. Any questions there?
No.
That one's just experience. That one's geometric. Geometric. Okay. Let us go back. Double angle. Okay. Let us do this one. Is it solving or something? Don't know.
Okay. So, if I did arc x equals to arc sine 3/4, I could do sine 2 times arc sine 3/4. Arc cos, sorry, arc cos, yeah.
Okay. And we're in degrees.
Yeah. It says find the exact value of, and it gave me a long number.
A in degrees?
Yeah.
Good. Serves you right for doing something that crazy. What is cos squared equal to?
1 minus sine squared.
Very true. Is equal to 1 minus sine squared x. And in this question, what else is cos squared x equal to?
3/4 squared.
Yep.
So I need to do 3/4 squared equals to 1 minus sine squared x.
Yep. Let's just sanity check. What is sine 2x the same as?
2 sine x times cos x.
There you go. So 2 sine x cos x. Cos x is exactly 3/4. And so all we need is exactly what sine x is, and then we'll have an exact value.
So for sine x, would that be 2 times sine arc cos 3/4?
2 times... you could try it.
Okay. No, bad answer.
Yeah, just inexact, I think. Okay, make sine x the subject.
What? So if I do, so but I have to do 1 minus 3/4 squared,
Mm-hmm.
and then equals to sine squared x. And then would that just be, so sine x is equals to square root of 1 minus 3/4 squared?
Yeah. What is 1 minus 3/4 squared?
1 minus 9 over, 9 over 16.
Mm-hmm.
And so that would be 7 over 16.
7 over 16. And you said it, so sine x is the square root of that?
Yeah.
You're half right. Plus or minus. But which one?
Plus, because it has to be 180. It has to be between 180 and 360.
Why would that make it plus?
Oh no, it'll be to do with where the sign is. So, because it's one. So if we do like the little quadrant thing, and then, so it's 180 to 360. So that's. What? Is that going to be? It's in the tan and C region. So would that make it negative then?
Yep. And so what is sine x?
Minus root 7 over 16.
Yep. And so we want the exact value of sine 2x.
2 times a minus root 7 over 16.
Yeah.
And do I choose to just multiply all those numbers together now?
Yeah, I reckon the calculator can manage that.
Yeah. Yeah. Minus 3 root 7 over 8.
Root 7 over 8. How could you check that we're correct?
Would I... Could I sub in minus 3 root 7 over 8 into...
I'm sure that'll work. Press SD, what does it say?
It says...
Does it give a decimal?
Yeah, minus 0.99921567416.
Look familiar?
Oh, it's from... Is that from small angle approximations or something?
No, that was the very first thing you said. You said the sine of 2 times the arc cos of 3/4.
Oh, right.
So
Okay.
we got it as a decimal, but we needed to get it as an exact value. I wouldn't have guessed that root 7 would be involved. And you'll notice your one is negative, our one is positive. By doing arc cos, we're losing the negative, and because we didn't take the quadrant into account. But,
Yeah.
But basically, that wasn't a coincidence. It's definitely correct. But you're right, you could sub it back in and all that. Okay, so we just found sine 2x, and exactly, how about tan 2x?
Okay. So... So we know that x is equals to... Would I have to do 2 times tan... Would I have to do 2 times tan minus roots... Oh, should I find out what cos of minus root 7 over 16 is?
If you do that, I think you'll get a decimal. You could try, and you might get lucky. But I think we'll just get a decimal thing again.
No, didn't get lucky.
It's actually crazy enough to work, but it's totally not what you're supposed to do. Sine 2x. So this was our sine 2x answer.
Yeah.
Okay, tan 2x. We have our thing for tan 2a.
Yeah, so... Will that just be 2 times tan... So minus 3 root 7 over 8, that's equals to sine 2x.
Yep.
I'm getting a bit confused, I think.
You also said sine x is minus 3 root 7 over 8. Question tells us cos x is 3/4. Identity.
Do I need to...
Mm-hmm.
2 tan x. So do I now need to eliminate x or something?
No. What's tan the same as?
Tan is the same as sine over cos.
Yep.
Oh, right. Divided by 1 minus sine over cos squared x.
Mm-hmm.
So should I now sub in the values?
Mm-hmm.
So minus 3 root 7 over 8. Oh yeah, time 2 times, sorry. Divided by 3/4. Divided by 1 minus minus 3 root 7 over 8 squared.
Mm-hmm.
Over 3/4 squared.
Yep. There you go.
Now I just put the entire thing into the calculator.
Yeah, I'd probably do it in 2 halves. Over 8 over 3 over 4.
I got minus 36 root 7.
Okay, minus 36 root 7, and that's for tan 2x quadrant.
It's in the tan quadrant, so will it just stay that way?
That means that tan is positive in the
So
tan.
so is it 36 root 7?
So I think it'll be 36 root 7. And we just put it in wrong somewhere in our calculator.
Oh.
So tan 2x. Hang on, was our part A wrong? Is that? Or did it just simplify down to something? No, our part A is correct. Sine x. Am I missing something? So sine x was my... Oh, my mistake. Sorry, we put in sine 2x. We should have just put in sine x. Sorry. My mistake. Yeah, sorry. Sine x was minus root 7 over 16. Sorry. Yeah, the sine 2x was that. Sine 1x. Yeah. Okay, that'd be simpler. Put in the calculator, you get the answer. Minus that. And let me try something crazy. 'Cause I can sense you want to do something crazy. Hang on. So sine x over cos x is tan x.
Yep.
Sine 2x over cos 2x is tan 2x. That means sine 2x I mean, that's kind of all you would need to do. Is that what we did? Yeah. So we said sine 2x was that minus 3 root 7. What was it? Minus 3 root 7 over 8. 8. And cos 2x. Oh, we didn't get cos 2x. That's the so wait, what is cos 2x the same as? Cos 2x would be the same as 1 minus 2. We could use that one. 1 minus 2 sine squared, so that one squared. I think that would work as well.
Wow. Yeah.
But and that would be tan 2x. And when you put that in your calculator, you should get the thing. We got it, and our way will work in general using that stuff. But in general, you put it into the formula to get it in terms of sine 1x cos 1x. We know that cos x is this fraction. We get sine x using our identity. You don't use the arc sine arc cos. You'll get an inexact value. This way, you'll get a square root. Check the sign using the quadrants, and then sub it in. Same for tan. Now that we have sine and cos, we just sub them in to get tan. It was my mistake. That was sine 2x, not sine 1x. Any questions there?
No.
Yeah, I told you this trig identities is the hardest stuff in A level, in my opinion. So what do you give yourself for this stuff?
I'll give it like 3/4. I'm getting there, but there are some things which can be a bit difficult.
Yeah, we haven't even finished it yet. I haven't even finished double angle formulae. Yeah, how was that for you?
Tricky, but I'll get there, I think.
Yeah, tricky, all right. Let's see, any questions for me in general?
No.
All right, well done, Andrey. You did great. And yeah, have a good weekend. Look forward to talking to you again next week.
Yeah, you too. Cheers. Bye.
Goodbye.